Alright, so we're going to do a video on how to use a graphing calculator, just in case you are a little rusty or haven't been experienced with it before. And I'm using example 3 on page 255 of your book. It says graphing a quadratic function that models a situation. So they give us a formula that we're going to need to put into our calculators in order to solve it. And it says an object is fired upward with a speed of 60 meters per second. Its height h in meters after t seconds is modeled by the equation, and it gives us this equation. Height is negative 4.9 t squared plus 60t plus 1.85. The good news is we don't care too much about the particulars, we just know that we need to be able to work with this formula. So it says to graph the quadratic function, which is our first thing to do. So what we're going to do is we're going to hit our y equals point here, and that's going to bring us up with a whole bunch of y options. And we're just going to punch in, we're going to use the negative button, which is this little dude down here, negative. And then this is your button for the variable, it's x t theta n, so negative x. There's a squared button here. Oh, I got ahead of myself. Back over this way. It was negative 4.9 and then x. I think I'm going to delete that part. Squared. Okay. That should move through. You can see that because this is one of the newer calculators, and yours are probably like this, it's got the cursor up with the exponent. I have to move it one more over before it drops back down. And I'm going to continue on with plus 60 variable. Doesn't matter that it's t or x, whatever, it's just the variable, plus 1.85. Now I've got my formula in there, and then I'm going to push graph. It takes a minute, and you can see that something's happened here in the middle, but it's not showing up very well, so there's a good chance that my window isn't set properly. My window, I'm going to hit window, shows me my minimum value for x, which would be the one on that side of the screen, and then my maximum value for x, so the one on this side, and my minimum for y, and my maximum for y. So in this scenario, I'm going to look at these numbers and go, okay, well, these numbers are probably going to be pretty big. I've got an object being fired upward with a speed of 60 meters per second, so it's probably going to reach a pretty high height. I could take a guess, and the seconds aren't going to matter. In fact, if I'm talking about time, my x minimum, that's my time. It's not going to be negative 10 seconds back into the past. So I could just hit this as negative 1 and then bring it down, and that's just going to show me very clearly where my axis is, but I'm not going to have a value on negative 1 seconds because, well, we haven't figured out how to time travel yet. So I could leave my x max at 10, just for now, it doesn't really matter. I can adjust it later. The x scale, just leave it at 1, I've never used it. Your y minimum, again, this is a real life situation, so my y minimum, it's not going down into the earth, my y being my height, so I'm just going to leave it. I can make it negative 1 just so I can see the axis nicely, but I'm not going to have a negative value there that's going to be useful anyway. And my y maximum, I'm guessing it's going to be a lot more than 26, so I could probably go with 60 times a few seconds, probably around a couple hundred. So let's say we'll set it to 200. Now my y scale, my x res, no one cares. Just leave those by themselves. Now we'll try graphing it again. So we hit the graph button. Oh, look, so pretty. There it is. Okay, we didn't quite get the far end of it, so if we want to get the entire graph, we can kind of look at the space here between where it starts and where it caps out. It's probably 6-ish. So I could probably go back to my window and adjust my x max. X max to be 15, and then that should show me, go back to my graph, that should show me the whole picture. Yay! Alright, so that's how you get a graph. What we want to do with it now is, well, first we're going to sketch it. So when we sketch a graph, we want to put some relevant points in there, and that's about it. So A sketch doesn't have to be perfect. See, mine's not perfect by any means. If it was, it would be symmetrical around axis of symmetry, and as you can see on your graph, that would be right there. Comes down to about there. But as I showed you on the last video, there's some stuff we can do under second function calc to get all those values. So we just sketch it. I can put in my values at, if this was 15 out here, then this value is somewhere around 12, and this value is 0. I'm not too concerned about it at this point. I'm just doing a quick sketch. So the next thing they want is identify and explain the significance of the intercepts. So I want my y-intercept, my x-intercepts, the coordinates of the vertex, so I'm going to want my vertex, and the domain and range. So those are pretty normal things for them to want. So my y-intercept for this graph is going to be at 0. And just to remind you, the way to get the y-intercept is I know that at the y-intercept, x is 0, and they have this fabulous little function here where it says second function calc, where it says values. I'm going to hit 1 for value. It tells me x equals, and I can put in any value for x, and it's going to tell me what y is. So if I want to find my y-intercept, the easiest thing to do is say, well, x is 0. Oh, look, y is 1.85. So it's really close to 0, but not quite. So my y-intercept is 1.85. Now, I want to find my x-intercepts, and those are what they call the zeros. So I'm going to go second function, calc, and zeros. So right now, I want to find my cursor. It says that my x is negative 0.14 and my y is negative 7, so they're kind of far off the other way. But I can probably just cheat and go, that's pretty close. So I'm going to hit enter. And then I'm going to move it over to right bound so that x isn't negative anymore. And then I'm going to hit enter again and guess. When y is 0, x is negative 0.03. So we could probably just say x is 0, because if you, significant figures being what they are. So when y is 0, I've got x is 0, which makes logical sense. And then I'm going to want to do that again. So second function calc again, 0. Have to reset that. And then, you see the little guy moving along there? He's got to go all the way across to the other side. And he's going left bound, so I want to stop him before he gets negative this time. Before the y gets negative, sorry. Okay. So that's good enough. Stop him there. Move him one more over. Hit the enter button again. And hit the enter button when it says guess. And y is 1 times 10 to the negative 11th, which is close enough to 0 for me. And it says that x is 12.27. So I could write down that 12.3 is probably close enough for our purposes. Now, the vertex is this point right here at the top. And to get the vertex, I'm going to go second function calc. It's a maximum because it goes up and caps out. So I'm going to hit 4. And it's the same thing with the little cursors. So I looked at the cursors. They're back down here again. I got to move my little cursor so that it's left bound heading toward the point I want, which means I have to move it to that side. And I can try to get it really close, but I find that it doesn't really matter. Okay, and then on the other side of the point that you want, you hit enter, enter again, and it tells us that at the maximum, x is 6.12 and y is 185.5. So my vertex point, because it's a point, is going to be 6.12 and 185.5. Well, 0.6 actually, because nope, 185.5. Shutting up. Great. So my domain is simply x is in the realm of all real numbers, because the domain extends both ways that way. The x is just keeping going. My range, however, y, is limited by the height. So my y value right here is going to be the maximum that my range can be. So y is going to be less than or equal to that maximum value of 185.5. Now, if they had asked us for the axis of symmetry, that would simply be x equals 6.12, because that is the value of x for the middle of the graph.